And we're live. Cool. So today I don't have much of a plan other than taking requests, obviously. So if you have any problem requests that you want me to work for you, let me know in the chat. But if you just want to hang out and watch, I think what we're going to probably work on is optimizing my LiDAR thing, LiDAR simulator. Because I had it, we did the math for it last week on the whiteboard, and the math works. But the way I wrote the code to do it used a dictionary data structure, which is a lot slower to access than like a NumPy array, which is what I ended up changing it to. Unfortunately, it's still slow. So I think what I'm going to do is alter it so that instead of being instead of calculating one distance at a time, we're going to batch check all of the walls. So the way it works right now, and you can see this, so very good. Right now it goes through all of the angles that it's going to be reading, and for every angle it goes through all of the walls. Which you have to do, but it loops over every wall, and loops in Python aren't as efficient as doing a batch calculation using linear algebra, since I have that option here. So what I need to do is I need to make these arrays rather than single elements, and I need to make this a 3D matrix instead of a 2D matrix. And then I need to make this a 3D matrix instead of a 2D matrix. And everything should, keyword should, work out nicely. So that's what we're going to try to do. I have this saved, and I'm going to work in commented mode rather than just deleting things straight up. I'll get rid of those comments because I don't need them anymore. I can get rid of that because I don't need that anymore. I can get rid of that. Get rid of those. I can get rid of those. And I can get rid of that one. And I can probably get rid of a bunch of this too, but I'm not going to bother with that just yet. What we want to optimize is right here. That's already done. This is where we're going to make our change. So instead of doing it for wall in walls, we're going to say wall dx is equal to wall, and I guess I'll go over to the marker board and show you how I have it stored, because I feel like that would be helpful. That one? Yeah, there we go. So right now I have it, where I have columns. So this is an array of arrays. That. There we go. So in the first column, we have x1, and then x2, and then y1, and then y2. And it doesn't necessarily make the most sense for it to be done that way, but that's how I did it. For better or for worse. I could have done x1, y1, x2, y2, but I didn't. I don't know that it matters a ton. So that's how we're going to do it. And this is, wall 1, wall 2, wall 3 all the way to wall N. And now when I show it to you, you're going to see that there is a curved wall. Because from the perspective of a robot rolling around, the leg of a chair is a wall, right? Because it's just a thing that it's seeing. And here, all I have are straight pieces. The way I'm getting the round wall is by making a bunch of little straight pieces. It's not truly round, but it's close enough for the sake of our simulation to use straight pieces. Let's go back to the code. Okay. So here we're going to take all of the first indices because that's the wall number. And the second one, we're going to say wall 0, wall 1 minus wall, all of the walls, first X component. And this actually needs to be and here. Position. Yeah, heading. I'm changing some of the structure here. So we're no longer going to have this parent thing. It's just going to be heading. This is going to be position 0. And this is going to be position 1. And I'm doing it this way because this sensor doesn't need to know anything about the robot. It only needs to know about the environment. And the numbers returned here are just to make the numbers work out nicer for the sake of the simulator, for the person who's going to end up using it. Actually, nope, I'll do it. I'll leave it the way I had it for now, because I want the interface for all of the sensors to be the same. No, I'm waffling. That's not what I want. Redo. I'm going to do it this way. Because no matter what sensor I'm using, it'll need to know the position of the robot and the heading. But I don't need to pass the entire robot in, I don't think. We can change it later if we need to. But we will do env dot walls, and this would actually be env dot walls. And the rest of this is all fine. I don't need to change any of the referencing things. Okay, so then we'll do wall dy equals same thing, but that one's going to be a 2, and that one's going to be a 3. Now, A is going to be this mess. Okay, so A is our matrix of pointing vectors, and for all of the walls, our sensor pointing vector will be the same, but our walls pointing vector will not. So we need to extend our sensor pointing vector to be long enough and the correct shape. Actually, there's an easier way to do this, I think. So if we'll make A the correct shape, np dot zeros, and I'll change the value in a minute, but for now we're going to initialize it to the right shape using np zeros. And so the shape is going to be walls dx dot shape. Actually, it's going to be env dot walls dot shape 0. So shape 0 is going to be the length, so the number of walls. And I think that needs to be the last dimension of this array for it to work. I don't know. We'll experiment and learn together. But this one is going to be 2 by 2. See, because it's too wide, too tall. And then it's going to be not helpful. Too wide, too tall, and then some number of walls deep. So then we'll do A and we'll set the first let's do a test real quick. Come down to the Python console, and probably for the sake of the stream I should be using Jupyter Notebook, but I'm not. I may upgrade later. Import numpy as np. So we're going to have it say 30 walls long. So A is going to be np dot zeros 2 by 2 by 30. A, okay, it gets to be a big mess. And if I do A, the first column, no, all of the columns or rows, I'm not sure which, 0, all of those is equal to 1, A, and then if I do A, just the first one, aha, that is what I want. And if I do this and say 1, 2, oh no. That's okay. That's okay. I can live with this because that means all I've got to do is change that to a 0 and that to a 1. Change that to a 1, that to a 2, and then theoretically yes. Okay, so that's what I need to do here. So I have to set the upper right position or upper left position, and that will be 0, 0, all of them equal to r dx, a 1, 0, all of them equals r dy. Now I need to set the other ones, and so now I need to test and make sure that that works. So if I do w dx for the sake of testing equals np dot a range 30. Whoops. then can I do a 0, 1, all of them, equal to w dx? Because that's what's in the thing. Yep. Right there. Yes, I can. And then 1, 1, dy, and then a this. Yes, I can. Very good. So this is the upper left corner, lower left corner, and then we'll do the upper right corner. A 0, 1, all of them equal to w dx. W dy. Okay, so now A, theoretically, is in the right shape. And we need this guy to be in the right shape. So let me check the documentation for, hang on, where is it? Here it is. NumPy pinv. Okay, so we're going to check the documentation for the pseudo-inverse function. Matrix or stack of matrices to be inverted. Ah, nope, I have the dimensions wrong. So the dimensions need to be this one first, I think, if I'm reading the documentation correctly. And so for those who've not used this before, in a lot of IDEs, it will let you select multiple lines all at once. I know it's kind of a little thing, and I've known about it for a while, but if you're editing a lot of code where you have stacks of things like that right here, being able to do that is super handy. So handy. So if I move this, can you see it? No, you can't. Okay. Stop. Okay. Let's hang on. I gotta move some stuff. Okay. Documentation that way. There we go. That's what I want. Then I wanted to do that. There we go. So according to the documentation, the matrix, or this pseudo-inverse finds the pseudo-inverse of a matrix or a stack of matrices to be pseudo-inverted. And the dimension is some number, which I'm assuming is the stack, m by n. So it's an m by n matrix with some unknown number of, or some unknown depth. Which is why we have some unknown depth by 2 by 2. So now this other matrix is our B matrix. And we can actually create that fairly easy, I think. So B equals np dot zeros. Actually, I might be able to just zip that. That's gonna be wall, okay. Let's test first. So in the test down here at the bottom, can I do clear? Nope. Okay, fine. We'll do this. I have wall x 10, wall y equals 0 to 20, no, np dot arange 0 to 20, so two elements, or two arrays of the same length. And I have sensor x, sen x equals 3, just as an example. Sen y equals -2, again, just as an example. Because those will be fixed numbers that don't vary for every wall. This is where the sensor is on the map. So we're going to have wall x, or we're going to zip np array. So we want to turn into an array the zip of, you want to zip it? Might be able to h stack it. np.h stack wall x minus sen x wall y minus sen y. Not h stack, maybe v stack. Can't tell. Wall x is -10. Okay, so we've done that. I believe that is correct because we got -10. But over here it's -13, or -13, -12, and this is one array. So then, what is the shape of this? 2 by 20. Can I just stack? Because I believe it needs to be 20 by 2. Doesn't matter. We can just swap axes. Swap axes, axes 0 and 1. It's 20 by 2, and that looks correct to me. Probably. We'll try it. B equals np dot, and I guess I can just do stack, since vstack and stack return the same thing. And this is going to be n dot walls, all of the walls, and I want wall 0 and 2. So yeah, okay, so I want wall 0 minus sensor x, and I want n dot walls 2 minus sensor y, and I'm gonna np dot swap axes, swap axes, np dot swap axes. And then theoretically, x equals np dot linalg dot p inverse of a at np at b Somebody want to do this one time and exit, because I just want to test it. So now we're coming down to the run, and I'm going to tell it to run, and it's going to crash because I forgot to do that correctly. Simulator. This guy needs to pass in self dot x self dot y, but that needs to be in a tuple, and self dot heading and self dot right. You have an environment. A robot has an environment. Env. And now we will try it again. Wall reference before assignment. Okay. Which means I just need to do env dot walls. All input arrays must have the same shape. Oh no, what are we talking about here? Let's see. Which array is not the same shape? Env walls 2. Oh. Forgot to tell it all of them. Now there's a problem. Axis 1 and axis 2. Still got to tell it 0 and 1. Helps if you finish. Mismatch in its core dimension. Size 43 is different from 2. Okay. Alright. Print A dot shape, B dot shape. That is 43 by 2 by 2 and 43 by 2. Looks like I had it right the first time. Colon there. You must move. I don't need to swap the axes. Back. That's not what I wanted. Okay. Does that... Ah, it worked. It worked. And it didn't throw up. Okay. 2 by 43 by 43 is the shape of X. Yes. Yes. So then I need then I need to remove all of the ones with a negative R or a negative T. So that means I can comment all of this. Right? Yeah. Yeah. I can comment all of that out. And this is going to actually end up being self.readings. Okay. So once I have that, now I need to go through, and anywhere I have an R less than the minimum, which is specified up here, min range. If actually x all of them in the first column, less than self.min range equals 0. So I'm going to set both the range and the length along the wall to 0 if the measured range is less than the minimum range. That way I can trim out all of the 0 elements later, or all of the 0 pairs. And then we'll do, do I need to do anything else there? Yeah, so then if I want to trim numpy remove 0 pairs np.all with access. Oh, well that's fun. Apparently on Stack Overflow, let me bring it up so you can see it. And yes, I am not above using Stack Overflow. So you can do it with just that. So the array not where all of the elements are 0, or all of the elements meet the criteria along axis 1. I wonder if I can just do x np dot all. No. Oh. I can just do it this way. X equals x, x 0 less than self dot, or not x less than self dot min range, print x dot shape, print x. And that should work. Nope, it doesn't. Invert not supported for the input type. Okay. Greater than or equal. Boolean index did not match indexed array along dimension 0. Oh. Dimension is 2, but corresponding Boolean dimension is 43. Okay. What does this mean? Print dot shape is 43 by 43. By 43 means what exactly? Because there's 43 walls, so from each, maybe we should go back and look at what that means. Let's see. So the first dimension is range measured by the sensor and distance, and then distance along the wall. That I got. Why is it 43 by 43? Is that redundant data? It is not. It is not. Because in the one-dimensional case, let's actually just test that real quick. All I gotta do is come over to my example simulation, change my LiDAR resolution to 1, and then it'll work. Except it's still 43 by 43. Sample simulation. What? What? Oh, yeah, because, that doesn't matter at all. Okay, yeah, so the reason that didn't matter is because this 43 comes from the number of walls, not from the resolution of the sensor. And I don't really want to change the environment. So, why is there... Why is there such a strange shape on that? Let's print 0. I don't know what this means. Even though I didn't want to, let's go ahead and change the environment. This is how I'm setting up my environment, by the way, in case you were curious. It's very easy. I made it JSON. So I need an array of items to make up the wall, features, if you will, to make up the walls. So my first feature is a rectangle. Second feature is a polyline. Third feature is an ellipse. And this will generate 2-point wall segments in this one. So this one goes in here and does magic to make wall pieces. And then spits it all out in self.walls, which I then access in other places, which is lovely and all that. So let's copy. Let's make a new one, new file. Sensor test config. I'm gonna get rid of all of that stuff. Nope, I'm gonna get rid of that one. Nah. Yeah. Yeah, let's get rid of that one. Get rid of that. Get rid of that. Get rid of that because it looks like I don't need it. And then let's change our example simulation to use sensor test.config. Simulation config must have key environment. That's because that's not the one I needed to change. I need to change this one. And this one, I'll just change from example environment to sensor test config. There we go. 2, 3, 3. Why is it 3? Good. Oh. Sure. I'm actually going to change this. So this will go from 0 to 1024. No, from 0, 0 to 0, 1024. So this will draw one line across the top of the screen, or the top of the environment. Okay, so 2 by 1 by 1. So there is one number here for each wall piece. But if I do this number and change it so that I have 2 wall pieces and go to 1024, 1024. So now there are two line segments. It's now 2 by 2. So first dimension is that set. Second dimension is that set. So ranges, length along the wall, and then, or maybe, I don't know. I don't know how it's displaying it. I just want the ranges. Okay, so this is just ranges. So that's some negative 8,000 pixels, 8,000 pixels, a tenth of a pixel, and an 8/10 of a pixel. Neither of which seem correct. If I take out this exit, oh, okay. It's pretty fast. And slowing down some because I'm doing this. I didn't draw the piece that I thought I did. 0, 0 to 0, 10, 24. That's vertical line that way. I meant to do 10, 24, 0, 10, 24, 10, 24. Okay, try again. There we go. I'm going to put my exit back in so that I only have to look at one. Okay, so this one is the correct answer. $5,000 pixels? No, it's not. What in the world? What? 50,000 pixels? What? Something's not correct here. And that's why we don't delete things. So let's keep that. And we will print self.readings I. Print that number. Hey, thanks for joining. 149. So this one is the correct answer. And somewhere in X, there is a correct answer. Oh, nope, it's right here. Okay. So that's 150 versus 149, probably just a difference in rounding or something. Okay. So both of those increase when I increase the number of pieces of the wall. So if I did this one, I did 0, 10, 24. Then I'll have 3 pieces, 4 points. And if I run it, then it goes 3, 3. And the correct answer is 150 still, or 150-ish. I wonder if I have to specify in my matrix multiplication tensor int? Relative to a tensor dot operation. Raise if a singular or not square in the above sense. This should be fine the way I'm currently doing it. By 6 by 8 by 3. What about matmul? Matmul. Do I have to specify an axis or something? Input arrays, scalars not allowed. Matrix product. If the last dimension of A is not the same as second to last. That one. Both arguments are 2D. They're multiplied by like conventional matrices. For 2D mixed with 1D, it's the usual. Stacks of arrays. Vector, vector. I don't know why it's not working. It's behaving a little weirdly. Ba-dum. And I don't see the same numbers. So what I would expect to see is if I increase the number of segments that the numbers I end up with in my arrays repeat themselves. So when I have it set to one segment, I will see those numbers, and then when I up it to 2 segments, the numbers from the first run will still be in the second one. I'll just have some new numbers, but I'm not seeing that because I don't see that 150-ish number anywhere in here, which tells me something's getting summed across that I don't want summed across. I just don't know where that is. Let's see. P and B. Let's do a test. Let's clear that out. So if I do A equals NV dot or array and I do nope, hey. Fine. We're gonna do 1, 2, -2, 1. Okay. And then B is going to equal -1, -2. And I should be able to do A at B. For a matrix multiplication, it gets me -3, -4. Now, if I tile these, so a tile equals A, or np dot repeat A, and I'm going to create a new axis. And I gotta tell it how many repetitions to do. We'll say 3, and this will be axis equal to 2. And we do the same with B. Then we have A and a tile, and we have B tile. Then if I do A tile at B tile, it complains. That doesn't make sense. That explains why my other thing's being funky. That does explain why it's being funky. Okay, so a dot shape, or a tile dot shape, b tile dot shape, so if I do a dot or a tile equals np dot swap axes, a tile 0 and 1, and 1 and 2. So I've essentially just moved that. Yep. And then do the same with B tile. Nope. Stop. B tile. And do a tile at B tile. That does not work either. A tile dot shape, B tile dot shape. What was it? 2, 2, 3. Oh, it's because it's all goofed up now. A tile equals that. But I want to change it. So instead of putting the last axis on the, or the new axis on the end, I'm going to put it at the beginning. And I'm going to set it to repeat along axis 0. So that's A tile, and then same thing with B tile and B. That's correct. That's what I want. That's what I want. Okay, so I do want my new axis on this to be in the first one. Or, yeah, to come first. All of that there. This gets put here. And then this guy is not the correct shape. So what's b.shape? Wow. Print b.shape. What? Oh, it worked? It did work. Okay, so I printed B shape first. Oh, and that's perfect. That's exactly what I was looking for. Didn't that fail earlier? Okay, I'll take it. Okay, so that's better. So now, if I run this again, then the shape of X is 3 by 2 by 3. Why is it 3 by 2 by 3? The 2 I know. I know where the 2 comes from. I don't know why that number is in there twice. Because I don't think it should be. It's in there 3 times. What? Alright, x equals mg dot swap axes in x 0 and 1. 2, 3, 3. Okay. It's in there 4 times, and I don't know why. I don't have a clue what that's about. Because the dimension with 2, or the axis with 2 is my vector dimension. So the first element will be range, and the second one will be t, or my parameter along the line, along the wall. But it shouldn't be the same range. Oh, yes, it should. Because if I let it run instead of exit, what? Update, read, and comment all of it out. Yeah. So the distance to this wall is the same? Did I have? Okay. So if we do this, I'm testing a theory and I'm not sure if my theory is correct. Okay, so that one is repeated twice. And I know what those numbers are. I don't know what those numbers are. Maybe I do. So if that's the distance to the first line in the list, the distance to the second line in the list, the third line, and the fourth line, because I should have 4 lines, which makes sense. I'm still swapping axes. What if I don't do that? Then I have 4 lines, 2 parameters, sorry, and then 4 I don't know where that number comes from. Can I say that? 150. So this is just the ranges. 150, 150. Why does it seem like there's 2 copies of everything? Because that is all an exact duplicate of this. No, it's not. This and this are duplicated. And I don't know why. That means I only need half of it, right? Does that hold up if I increase the number of segments? Not sure. Let's see. Copy all of that. All of this. Actually, no. We'll just use this one now instead. Example, environment. Okay, so now it's the whole 43 by 43 thing. Let's go to the whiteboard. Probably should have gone there sooner. Whiteboard, or blackboard, I guess. Okay, if I have an array, or if I have a matrix that's 2 by 2, times a vector that's 1 by 2, and actually, you know what, r and negative t. Then when I multiply these out, I end up with a times r minus b times t and c times r minus b times t, or d times t, which is a 1 by 2. So 2 by 2, I guess it's 2 by 1, times 2 by 1 equals 2 by 1, because these guys go away, and you're left with this by this. I follow that. But there's something fishy when I expand it to a to this. Times this. Because I thought it should just do the same thing as up here, but in a batch. But it's not. Maybe I need a tensor dot? Maybe we'll try the tensor dot. Can't hurt anything, right? Let's you down over here. So instead of this, we will do np.linhouse.tensor, nope, right, tensor dot, nope, shape mismatch. Okay. Matrix multiplication on list of matrices. I want either multi-dot. No, that's probably not correct either, because that's a dot product, and I don't want a dot product. Matrix on batch. Batch to tensor. That's number. I don't want to use number. Aha. I believe. Nope, that's not gonna work either. I am unsure. Yes, that. Okay, so I found somebody on Stack Overflow who's trying to do the same thing as I'm doing. And okay, they're using einsum, or however you pronounce it. Whoops. You don't need that. So instead of tensor dot or regular matrix multiplication, they're doing B of A and B and B dot einsum. How are they doing it? This is taken from Divacar on Stack Overflow. literally going to shamelessly copy and paste because I don't know how to use that function. So there's that. Matrix 1, matrix 2, and then see if that works. No. What? Why is this not working? I think this was meant to go on here, perhaps? Nope. So this one has IJK, this one has IJ. What? Okay. Print A dot shape, B dot shape. 4322. And this should be is that I or J? Probably that, and then this needs to be K. by 2. 43 walls, so this is arranged each of the walls. And I would believe that. Yes! Okay. Thank you at Divakar for the solution to my problem. It would have taken me forever to come up with that. So now if we print X, yeah, there we go. Yeah, that's perfect. That's exactly what I needed. So get rid of that. And I'm going to leave this in a comment and explain. Batch-wise matrix multiplication according to formula that. So this is the formula, but this is the batch-wise implementation. Okay, very good. Now I can proceed to filter. So get rid of that because I don't even remember what I was thinking with it. So if we have X, which now contains ranges and stuff, then X, we can make that equal to X everywhere the first column of X is less than, or is greater than or equal to self.minRange. Print X.shape and print X. Aha, so we got rid of a bunch of them. And then now we can do x equals x everywhere that this one is greater than 1 or no, is less than or equal to 1 or and, because this is filtering out the wall. So greater than 0. Okay, so this is check to make sure the measured point is in front of the sensor, and I actually should change this to 0. Make sure it's in front of the sensor, and then this one is check to make sure measured point is on the wall. So what we ended up doing is we ray cast to the wall and from the sensor to the wall. Now, if the sensor ray passes through a line that's collinear with the wall, we get a point. But our parameter in x1, if this parameter, and I'm actually going to swap this order. That way it's a little bit easier to see mathematically. So if that parameter is greater than 1, then we've gone past the end of the wall, which is irrelevant because we're now no longer on the wall itself. If it's less than 0, you've gone off the wall the other way. Oh dear. Maybe we'll just do these one at a time. Duplicate. Paste. Okay, but now it's returning nothing. Comment those both out. Why is this funny? It shouldn't be acting funny. What does this one return? He says 149.22. So this is the correct one. But why is t funny? T should not be a negative number. It's really small. T should be a positive number there. Oh, that's negative t. Just kidding. if I do this, nope, not that. If I do that, that should correct it. Yes, it does. Very good. And then I should be able to throw those checks back in. And I end up with one measurement this time. Yay! But that's just in this case we end up with one measurement. If we rotate it, so let's comment all of that out. And pick this moment, for example. There's now 3 or 2 in front of it that it could catch. So let's actually freeze it in place. We'll set the start heading to np.pi over 180. I believe, yeah, I have heading set up to be in degrees because it seemed like the thing to do, mostly. And this is going to be 1. No. No, it's not in degrees. It's in radians. Pi over 2 times 1.3 seems about right. Oh, yeah, that. This is the wrong simulator file. My bad. My bad. Not here. Here. Comment all of that. And this needs to be pi divided by 2. Sure, we'll try that. Okay, so yes, there are 2 options now. And if I come back over here and re-enable that. So now there are 3 lines. I don't know where that comes from. I really don't. So now we need to add the check for minimum range. Not min, and we want greater than or equal to, not min range, self dot min range. There we go. So that's the 2 points in front of it. And then we want to sort, and we only want to return the closest one because it can't see through walls. So then we want self dot reading readings I equals np.min x all of the first column. Which will now return what we want it to. We can do that. since erase, I'll change this so that it matches position, heading, environment. Now that should stop complaining, and this should run. We'll rename all of these things. That is way better than it was before. Look at that speed. You can't see it. Look at that. This guy was crawling before, and now he's super fast. That is way better. I wonder if I set the frame cap higher, example. Okay, so that's the fastest it'll update. That's still way better. Yeah. I can make that work. That can be fast enough. All right, well, I think that's going to be it for today. And we will, I think I'm going to stream again Tuesday next week. And not Thursday, obviously, because it's Thanksgiving. And I am going to be stuffed and hanging out with family. And in no condition to stream. So if you guys have enjoyed this, if this was interesting to you, I know I spent a lot of time staring at the screen and going, what? I don't understand. But if the project is interesting, hit the like button, hit subscribe. We do all kinds of this stuff. If you have homework problems that you want help working, put them in the stream chat, join my Discord, and put them in somewhere in there. You can find the link in the description below. Sometimes I'll check the Discord, and if I can help you with the problem right away, I'll help you there. Otherwise, I may address it in a stream. Ta-da! I think that's all of the selling out that I can do. So, yeah, be sure to hit the like button, hit subscribe, and we'll see you guys next week.